Hey guys, I'm Cameron Fife, and this is my SPED talk for week 13. So I'm going to be talking about two things today. Some context, I work with Carson Woodford, and together we work on a computer vision project for senior projects. The first thing I want to talk about is called YOLO. And the second thing I want to talk about is called neural network freezing. Okay, but before I even talk about that, I want to talk about my computer vision project. So me and Carson are working on a project called automatic parking detection. So what that means is, well, the basic idea is, what if you could know if a parking lot is full using computer software? And the way we ended up approaching this is using machine learning with computer vision. So here is a photo of actual, our application being used, and just you can see it detecting photos. I'm going to show you the clip right now. All right, so they're all white, but they don't have to be white. It's just one example. Now that that's out of the way, let's talk about YOLO. So YOLO is a very new algorithm and model for performing object detection. Object detection is the process of detecting specific objects in a picture. Note that this is very different from what's also known as image classification. So for example, here I have a very nice picture of a cow. Image classification would be basically saying that this is a picture of a cow. But the problem with this is, in image detection classification, you don't actually specify where in the picture the cow is, and you also don't specify how many cows are in the picture. So this is how classification is different from object detection. So in object detection, I can now have two cows, and not only that, but I can specifically say where each cow is in the picture. Okay, and here is just a very quick, cool kind of live demo of YOLO actually being used in real time. So it's really neat. So YOLO is uber fast, and that's kind of the reason why it's kind of the state-of-the-art model for object detection. The way it sort of works is that it splits up an image or a picture or a video frame into different sections, and it tries to do classification, and it does proposals on each one of these sections. And this is kind of how it only just shows the things that it has a high confidence for. Now, this can run super duper fast. This is obviously a video that's been pre-processed, but if I were running this in real time, I could do this at running around 20 frames per second. So you can really kind of detect objects in real time. So it's a very powerful tool for something like kind of automatic driving cars. So that's what YOLO is. It's super cool. It's kind of the state of the art for object detection right now. Okay, so the second thing I want to talk about is something called neural network freezing. So I don't know how familiar you guys are with neural networks, but here is a very simple one. And you can see here that you have the input, you have kind of the different layers, and then you have the output, which is sort of saying, yes, it's a car, no, it's not a car. And this is not what an actual image neural network would look like. So normally, when a neural network is being trained, you're going to update all layers of the neural network. But this is different with what we do. So there's a concept called neural network freezing, which basically says, well, what if I don't change these layers and I only change kind of the last, some number of layers? And so this kind of allows me to change kind of the icing of the cake without having to change the cake. So this is just a very fast way to, this allows me to train my model to detect cars on only a couple hundred images rather than, thousands or tens of thousands. So that's neural network freezing, and before that is YOLO. And those are the two things I wanted to talk about for my SPED talk. So thank you.